Okay, we have the temperature function T hours after 9 a.m. So the temperature function is a function in T, where T is how many hours after 9 a.m. Is given by this formula. We need to compute the temperatures at 9 a.m., temperature at 3 p.m., and the average temperature from this to that. Okay, so temperature at 9 a.m. Then T is, say T0 is how many hours after 9 a.m. This is 0 hour after 9 a.m., right? So it is 0 hours after 9 a.m. So just plug in this formula. So T0 equal to 0. So this is T0 0 0 0 times 0. So we have 80 plus 10 sine of 0, right? Sine of 0 is 0, so this is 80 degrees. What else? The second one is temperature at 3 p.m. So 3 p.m. is 15, right? So we have the second one, temperature at 3 p.m. So T1 is how many hours after 9 a.m. So it's 15 minus 9. So we are at 3 p.m., which is 6 hours from 9 a.m. So 6 hours from 9 a.m. Therefore, we just plug in this formula for T1 equal to 6. So for T1 equal to 6, this is 6 and 6 pi. So what is this? 80 plus 10 sine of pi over 2, right? So pi over 2 is here, sine pi over 2 is 1. Plus 10 times 1, so it's 90 degrees. And we are done with the second part. What's the last one? The average from 9 a.m. to 9 p.m. 9 a.m. so 0. So from 9 a.m. to 9 p.m. this is 21, right? So we have this one give us, say, T 0 is 0. So 0 hours from 9 a.m. From 9 a.m. And this gives us T1 is 21 minus 9. So 12 hours from 9 a.m. Therefore, we need to compute. Okay, recall one more time that the average value of a function, say f of x, for an interval from a to b. So for the interval a comma b is 1 over b minus a from a to b of f of x dx. That is the formula for the average function. Then in our case we have from 0 to 12. Okay, so 1 over 12 minus 0 from 0 to 12 of this function. No, of the function t weighs up here. Big T of small t, this one, dt. Okay, so we have now is this one, 1 over 12 80 dt, right? So we have 0, 12, 80 dt plus 1 over 12 interval of 0, 12, 10 sine of pi t over 12 dt. The first one, let's compute this easy one first. This is 1, so 80 over 12, 0, 12 dt, right? Which is 80 over 12 times 12. So this is this x. Maybe I do small slowly. So x or t, where t is from 0 to 12, right? So this 80 over 12 times 12. This is 80, so we are good with this. The second one, so remember that the first one is 80, the second one is here. We have this one, maybe we do U substitution. This one is 10 over 12. 0 to 12 sine of pi t over 12 dt. So let's put u be pi t over 12. So du is pi over 12 dt. Okay, so this is sine of u, and dt is 12 over pi du. dt is 12 over pi du. So this interval is 10 over 12 times. Okay, let's compute the boundary. This we have t from where to where, 0 to 12, right? Therefore u is from pi over 12 times 0, so this is 0. Pi over 12 times 12, this is pi. So we have u from 0 to pi. So 0 to pi sine of u dt is pi 12 over pi du. So this is a constant, just take it out. So we have 10 over 12 over pi, 0 pi sine of u du. So we have this one and this one cancel out. 10 over pi cosine, so actually minus cosine from 0 to pi du. This is 10 over pi minus, put it out there, then cosine of pi minus cosine of 0 minus 10 over pi. So cosine of pi is minus 1, cosine of 0 is plus 1. So this is 220 over pi. Okay, so the second one 20 over pi. So let's put them all together. We have put them on together. This one is 20 over pi, and the first one is 80. This one equal to 80 plus 20 over pi. Yep. So you compute it. It's equal to something like 86 something. Say blah 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 degrees Fahrenheit. Yeah.